Today I'm going to be talking with Apple about the Mac and Apple Silicon, specifically the recently released M2 Pro Mac Mini and the M2 Pro and Max MacBook Pros, as well as Apple's approach to designing and developing its chips. Now, in my M2 Max MacBook Pro review, I mentioned that it's the best laptop available for pros, so I am super excited for this conversation. I've got Laura Metz, the Director of Product Marketing, Anand Shimpi from Hardware Technologies, and Tuba Yalcin, a 3D and Pro workflow expert, joining me. So let's jump in. Hey guys, it's great to see you. First of all, I just want to thank you for your time today. Thanks for joining me.
Thank you very much for having us.
All right, before we jump into some of the details, I want to find out from each of you guys, how did you get into using Apple products or the Mac in particular? What's your origin story there?
Well, my first experience using a Mac was in high school, and I had to use a Mac that the school provided to start scholarship applications. And so that was my first experience jumping in on word processing and using a Mac there. And then it actually wasn't until, unfortunately or fortunately, until I started working at Apple nearly 20 years ago, that I fully switched to a Mac and made that part of my daily life, and of course have never looked back.
Yeah, for me, I think early on in school, I was exposed to kind of Apple computers. I had an Apple IIe at home a long, long time ago. But, in my adult life, it was kind of college when I really got into the Mac. I remember I was taking a kind of a compiler architecture class, and the Mac was disproportionately represented in that auditorium. And I remember looking over at people next to me, and they were doing all this really cool stuff on the Mac, and that ultimately kind of piqued my curiosity, and that's how I ended up picking one up kind of in the early 2000s.
And yeah, for me, it was always a MacBook Pro. I really liked what it represented. It was a device for the creatives, and I felt like having one, being a creative was like the lifestyle choice I was making, committed to my creativity. And I think when the iPhone was launched, I thought the iPhone and the Mac, these are the ecosystem, the power tools that will enable me.
So obviously I'm talking to three different people at Apple from three different teams. And it was probably on purpose that it was set up this way because that's how you guys design products in the first place. Apple doesn't just buy different components from different manufacturers and put them all into one product and then ship it. Instead, it's really different teams that all come together to make and form the final product. So could you guys tell me how that process works behind the scenes?
We really do create our products using a very collaborative approach across many different disciplines, whether that's, from design, hardware, software engineering. We've got Anand with hardware technologies here, and our pro workflow team, which we believe is very unique to Apple. And I wouldn't even say we start a project. It's like the projects don't end. We might ship a product, but we're constantly communicating, and those same conversations, they just continue on to the next as we continue to innovate and move things forward.
I will agree with Laura's comment. As a pro workflow team, we really need to work collaboratively across different teams at Apple because it's everyone coming together and making these changes happen. It's super collaborative, and it's really nice to see the efforts of that collaboration when the display team was part of something, and then the GPU team was part of something, and the OS team was part of it. It really makes a difference, and I think that's why some of the features we bring shows that. And I think the users also appreciate it, that it's not just one thing that's being great, it's everything all together being gelled perfectly.
Yeah, the Silicon team doesn't operate in a vacuum, right? I think when these products are being envisioned and designed, folks on the architecture team, the design team, they're there. They're aware of where we're going, what's important, both from a workload perspective as well as the things that are most important to enable in all of these designs. And so, I'd echo the same thing. It is very collaborative.
That makes sense. And as a creative myself, I still remember my first real interaction with a Mac. This is about 17 years ago, walking into an Apple store. And what caught my attention when I was playing with the Mac was I minimized the window and it kind of genied down into the dock. And I was almost taken aback by that action because it was so different. Just that interaction felt so different from what I was used to on the PC side of things. And it made me just want to explore the Mac and Mac OS more. So I literally walked out of that Apple store with a Mac Mini, the first Mac Mini, and I haven't looked back ever since. So needless to say, I'm a big Mac fan and I'm excited to get into it. Let's start with the design of some of the products that you just launched. Obviously, there is the new M2 Mac Mini, but I'm focusing more on the MacBook Pro with this question. You just launched the M2 Max and M2 Pro MacBook Pros, and at the beginning of this design generation, if you will, we saw the return of things like different ports and MagSafe. Now, Apple in the past has never been a company that shied away from dropping what it considered to be legacy ports or legacy technologies. But here we saw these things return. So could you tell me a little bit about how Apple settled on the designs of the 14 and 16-inch MacBook Pros, as well as the decision to actually bring ports back for its users?
Overall, designing the new 14-inch and 16-inch MacBook Pro that debuted with the M1 Pro and M1 Max was incredibly exciting because it was the first time we had Apple Silicon going into these Pro products, and we knew there was these things we would be able to do and have the vision materialize for products previously we'd only been able to imagine. And I think knowing how well the 16-inch MacBook Pro was received when it was launched, we wanted to be able to bring more screen real estate across the MacBook Pro product line. And so excited to bring the 14 and 16-inch together when we launched that product. And I think overall, I mean, you asked specifically about the ports themselves. Of course, we always drive to have the thinnest products that we can, just really that they are easy for you to carry around, right? It's all about, we want you to be able to have this mobile powerhouse with you. And certainly thin and light plays a part of that. And with Apple Silicon and this new design, we were able to bring HDMI and SD back. We know having a wide array of ports can certainly benefit Pro workflows. So we were excited about that. And then, of course, bringing MagSafe back with more support for its capability for charging and fast charging. So we were excited about that. I think we all also have stories about how MagSafe has helped protect our Mac in various scenarios.
And talking about those two sizes of 14 and 16 inches, with Apple Silicon, you're able to provide the same power regardless of which one the user chooses, which is generally not typical. Usually the smaller device you get, the less powerful it is. And that's not even taking the M2 iPad Pro into account, where you just have all this power in a super thin device. Can you give us some insight into how you're putting increasingly more powerful chips into increasingly smaller devices over time?
Yeah, so I think part of what you're seeing is this decade plus long kind of maniacal obsession with power efficient performance and energy efficiency. If you look at the roots of Apple Silicon, it all started with the phone and the iPad. And there, we're fitting into very, very constrained environments. And so we had to build these building blocks, whether it's our CPU or GPU, media engines, neural engine, to fit in something that's way, way smaller from a thermal standpoint and a power delivery standpoint than like a 16-inch MacBook Pro. And so I think the fundamental building blocks are just way more efficient than what you're typically used to seeing in a product like this. I think the other thing that you're noticing is for a lot of tasks that maybe used to be high-powered use cases, on Apple Silicon, they actually don't consume that much power. If you look at like compared to what you might find in a competing PC product, depending on the workload, we might be a factor of 2 or a factor of 4 times lower power. That allows us to kind of deliver a lot of these workloads that might have been high power use cases on a different product in something that actually is a very quiet and cool and long lasting sort of use case. The other thing that you're noticing is that single threaded performance, so the snappiness of your machine. It's really the same like high performance core, regardless of if you're talking about a MacBook Air, 14-inch Pro, 16-inch Pro, or like the new Mac Mini. And so, all of these machines can accommodate one of those cores running full tilt. Again, we've turned a lot of those usages and use cases into low power workloads. You can't get around physics though, right? So if you light up all the cores, all the GPUs, the 14-inch system just has less thermal capacity than the 16, right? So depending on your workload, that might drive you to a bigger machine. But they're really, the chips are kind of across the board, incredibly efficient.
Yeah, and when you said you can't beat physics, that's an interesting statement because it's obviously true. But at the same time, Apple Silicon's been such a revelation in the industry because while you can't beat physics, no one is coming as close to beating it as Apple has with Apple Silicon. And I think what you just said is a good point. When it comes to single core, whether you buy an M2, M2 Pro, or M2 Max, when it comes to single core performance, you get the same experience. And that's regardless of which chip you choose, which hasn't been the case in the past. So when you were choosing between a Core i3, i5, i7, or i9, if you went with a Core i3, you might see a delay if you have too many tabs open or just trying to launch your email app versus going with a higher end chip. Contrast that with Apple Silicon and you can get a base level M2 and start editing 8K video. But the other side of the coin that you mentioned, I did want to touch on battery efficiency. So there's all this power there, and at the same time, while these devices are thin and lightweight, you're giving us more battery life in the same size chassis with double-digit performance gains on both CPU and GPU. So I think the question on a lot of people's minds is, how? How is it possible to ship a Mac with the longest battery life ever while also giving double-digit performance gains in the same size computer?
We, of course, have this incredible chip, and Anand will speak to what we did there to improve the efficiency and get more battery life. In addition to that, we're always working with a number of teams to make many optimizations to get the most out of the hardware that we have. And so that includes working closely with Mac OS and firmware, across the system entirely to really optimize things so we are getting the most out of it.
Yeah, I mean, I think if you look at how chip design works at Apple, one, you have to remember we're not a merchant silicon vendor. At the end of the day, we ship product. And so the story for the chip team actually starts at the product, right? There's a vision that the design team, that the system team has that they want to enable. And the job of the chip is to enable those features, enable that product, and deliver the best performance within the constraints, within the thermal envelope of that chassis that's humanly possible. And so if you look at kind of what we did going from the M1 family to M2 Pro and M2 Max, at any given power point, we're able to deliver more performance. If you look at on the CPU, we added 2 more efficiency cores, 2 more of our E cores. And that allowed us to deliver it was part of what allowed us to deliver more multi-thread performance. Again, at every single power point where the M1 and M2 curves overlap, we're able to deliver more performance at any given power point. The dynamic range of operations a little bit longer, a little bit wider. So we do have a slight increase in terms of peak power, but in terms of efficiency, kind of across the range, it is a step forward versus the M1 family. And that directly translates into battery life. The same thing is true for the GPU. It's kind of counterintuitive, but a big GPU running at a modest frequency and voltage is actually a very efficient way to fill up the box. And so that's been our philosophy, dating back to phone and to iPhone and iPad, and it kind of continues in the Mac as well. But really, the thing that we see, the thing that the iPhone and the iPad have enjoyed over the years is this idea that every generation gets the latest of our IPs, our latest CPU IP, latest GPU, neural engine, media engine, so on and so forth. And so now the Mac gets to be on that cadence too. And if you look at how we've evolved things on the phone and iPad, those IPs tend to get more efficient over time. There is this relationship. If the fundamental chassis doesn't change, any additional performance you deliver has to be done more efficiently. And so this is the first time the MacBook Pro gets to really enjoy that and be on that same sort of cycle.
It is incredible. And I want to bring Tuba in on this as well, because I was excited to find out that we were going to have someone from Apple's Pro Workflows team here. No, I'm just assuming here, but it seems obvious that a lot of what we're seeing these days from Apple has been at least informed by the Pro Workflows team, which I believe was announced back in 2018. Can you give me a rundown of who this team is comprised of and what type of feedback and information Apple gathers from it?
Absolutely. We have some incredibly talented creatives who are area experts in audio, music, video, photography, 3D visual effects industries, and we are paired with super smart system architects. And together we work on these very complex, challenging Pro workflows and make them run awesome on the Mac. So it's a fun collaboration between technology and art, and we kind of gather both sides together and make them, run perfect on the Mac.
So what are some of the results of the Pro Workflow team? Apple put the team together in conjunction with the announcement that the 2019 Mac Pro would be coming in the future. So the team has been there for a while now. Can you talk about some of the things that consumers are directly benefiting from and using in Apple products today that maybe we might not have seen if not for the Pro Workflow team?
I mean, it's a collective effort. I think we, as a Pro Workflow team, we work very closely cross-functionally across Apple, whether it's hardware or software. And we've been championing for these Pro features that we want on the platform and constantly push for more performance. But we also look for the future and see what's coming. And so there's always innovation in our minds, and we kind of trying to keep up the pace when it comes to innovation as well.
Often we'll hear people in the media say that Apple won't make this product as powerful as this other Apple product because then it would cannibalize the sales of the more expensive product. And that kind of flies in the face to what Steve Jobs famously said, and I'm paraphrasing here, that if anything is going to cannibalize an Apple product, it should be another Apple product. And it really feels like we're seeing that mantra kind of play out with the launch of the M2 Pro Mac Mini. For the first time, you're giving the power of the MacBook Pro to users of the Mac Mini. And the result here is you no longer need to buy the more expensive MacBook Pro if that's the level of performance you want, but don't need the portability. So can you talk a little bit about that philosophy of what the M2 Pro Mac Mini in particular means to the Mac lineup?
I think it was a real exciting announcement and got a very positive reception because it is something new. I think it was somewhat unexpected given we announced this amazing Mac Studio product just last year. And I think it's just exciting to have these options that give users that flexibility that with Mac Mini, with the M2 Pro, that really is a broad range of performance based on your user needs. And if you need to take it further, you have Mac Studio. And then, of course, pushing that to the extreme, you have Mac Pro. So I think just, again, we want to just serve those customers and their needs and give them that choice and flexibility. So we're really excited to bring M2 Pro to Mac Mini.
On the silicon side, the team doesn't pull any punches, right? I think the goal across all the IPs is one, make sure you can enable the vision of the product. So if there's a new feature, new capability that we have to bring to the table in order for the product to have everything that we envisioned, that's clearly something that you can't pull back on. And then secondly, it's do the best you can, right? Get as much down in terms of performance and capability as you can every single generation. And I think the other thing is, at the end of the day, Apple's not a chip company. At the end of the day, we're a product company. So if what we want to deliver, whether it's features, performance, efficiency, if we're not able to deliver something compelling, we won't engage, right? We won't build the chip. And so each generation, we're motivated as much as possible to deliver the best that we can.
Obviously, as a tech reviewer, I have my own opinion on what I recommend people buy for their own specific needs. But from Apple's perspective, you have the range, as you mentioned, the Mac Mini, the iMac, MacBook Pro, Mac Pro. Do you have a philosophy towards how you would recommend a consumer make a choice when they're looking at the lineup and making a purchase?
Oh, that's an interesting question. We really want to put that in the hands of the user based on their needs. And I think, our goal is to make sure if they're looking for that everyday product that they have options for both a desktop and a laptop. And if they are pushing their creativity and need more performance and going to that pro level, they also have amazing options for a desktop and a laptop.
Okay, let's have some fun and move on to the explain it like I'm 5 years old section. I think there's some things that people understand for the most part and some things that they might not grasp that I'm hoping you guys can help clarify. So one of the things I think a lot of people don't fully grasp is the neural engine. I think they understand the CPU and the GPU and the RAM, at least for the most part, because they understand the direct benefit of each of those things. But the neural engine feels a bit more mysterious. So how would you explain what the neural engine is and how it directly benefits the customer?
Yeah, so I'll take the first half of that, and then I think Laura can chime in with some of the customer benefits. There are really two things you need to think about, right? The first is this trade-off between a general purpose compute engine and something a little more specialized. So if you look at our CPU and GPU, these are big general purpose compute engines. They each have their strengths in terms of the types of applications you'd want to send to the CPU versus the GPU. Whereas the neural engine is more focused in terms of the types of operations that it's optimized for. But if you have a workload that's supported by the neural engine, then you get the most efficient, highest density place on the chip to execute that workload. And so that's the first part of it. Second part of it is, well, what kind of workload are we talking about? And our investment in the neural engine dates back years ago, right? So the first time we had a neural engine on an Apple Silicon chip was A11 Bionic, right? So that was 5-ish years ago on the iPhone. And really, it was the result of us realizing that there were these emergent machine learning models that we wanted to start executing on device. And so we brought this technology to the iPhone, and then over the years, we've been increasing its capabilities and its performance. And then we made the transition to the Mac to Apple Silicon. It got that IP just like it got the other IPs that we brought, like things like the Media Engine, our CPU, GPU, Secure Enclave, so on and so forth. So when you're going to execute these machine learning models, performing inference on these inference-driven models, if the operations that you're executing are supported by the neural engine, if they're fit nicely on that engine, like I said, it's the most efficient way to execute them. Now, the reality is the entire chip is optimized for machine learning, right? So a lot of models you will see execute on the CPU, the GPU, and the neural engine. And we have frameworks in place that kind of make that possible. But the goal is to always execute it at the most, in the highest performance, most efficient place possible on the chip.
And I would just add that the end benefit of that is just more performance, and your system is doing more for you and you're not even aware of it. One great example would be things we do with our image signal processor, that it is taking information from that image coming in and adjusting your image and optimizing your image. So there's benefits across the board, and I think the magic is you don't even know it's happening. It's all done for you and highly optimized.
Okay, next, the nanometer process. I think this is another one that the average person doesn't quite fully grasp when they see it mentioned in a keynote. So how would you explain what this is and the importance of decreasing that nanometer process size?
Yeah, so here I think you're referring to the transistor. These are the building blocks by which all of our chips are built out of. And the simplest way to think of them is like a little switch. And we integrate tons of these things into our design. So if you look at M2 Pro and M2 Max, you're talking about tens of billions of these. And if you think about large collections of them, that's how we build the CPU, the GPU, the neural engine, all the media blocks. Every part of the chip is built out of these transistors. Moving to a new transistor technology is one of the ways in which we deliver more features, more performance, more efficiency, better battery life. So you can imagine if the transistors get smaller, you can cram more of them into a given area. That's how you might add things like additional cores, which is something you get in M2 Pro and M2 Max. You get more CPU cores, more GPU cores, so on and so forth. If the transistors themselves use less power or they're faster, that's another method in which you might deliver better performance, better battery life, better efficiency. Now, I mentioned this is one tool in the toolbox. What you choose to build with them, the underlying architecture, microarchitecture, and design of the chip also contribute in terms of delivering that performance, those features, and that power efficiency.
Okay, and as we've seen in the past, you can still improve a chip and make it better, even without decreasing the transistor size.
Yeah, so if you look at the M2 Pro and M2 Max family, we talk about them being on a second generation 5 nanometer process, and as we talked about earlier, right, the chip got more efficient at every single operating point. The chip is able to deliver more performance at the same amount of power.
All right, and next, the media engine. When you look at the Afterburner card in the Mac Pro and then compare it to the size of the media engine on the M2 package, it's just hard for me to wrap my head around these performance gains. How did you take something that was so large and then fit it onto something so tiny and give it more performance?
Yeah, and I think that's, going back to the point around transistors, I think taking that IP and integrating it on, the latest kind of highly integrated SoC with the latest transistor technology that lets you, run it at a very high speed and you get to extract a lot of performance out of it. And I think the other thing is, and this is one of the things that's fairly unique about Apple Silicon, we build these highly integrated SoCs. Right. So if you think about, the traditional system architecture in a desktop or a notebook, you might have a CPU from one vendor, a GPU from another vendor, each with their own sort of DRAM. You might have accelerators kind of built into each one of those chips. You might have add-in cards as additional accelerators. But with Apple Silicon in the Mac, it's all single chip, all backed by a unified memory system. You get a tremendous amount of memory bandwidth as well as DRAM capacity, which is unusual. Right, in a machine like this, normally, a CPU is used to having very large capacity, low bandwidth DRAM, and a GPU might have very low capacity, high bandwidth DRAM. But now the CPU gets access to GPU-like memory bandwidth. The GPU gets access to CPU-like capacity, and that really enables things that you couldn't have done before. Really, if you're trying to build a a notebook, these are the types of chips that you want to build it out of. And the media engine comes along for the ride, right? This is technology that, we refined over the years building for iPhone and iPad. And these are machines that, the camera is a key part of that experience. And being able to bring some of that technology to the Mac was honestly pretty exciting. And it really enabled just a revolution in terms of the video editing and video workflows.
How has the media engine kind of evolved over time?
I think one of the things that was pretty exciting, and it goes back to your question around how do we work with teams like the Pro Workflows team, I think the addition of ProRes as a hardware-accelerated encode and decode engine as a part of the media engine, that's one of those things that you can almost trace back directly to working with the Pro Workflows team. Right, this is a codec that it makes sense to accelerate, to integrate into hardware. It's important for both our customers, the people that were expecting to buy these machines. And it was something that, the team was able to integrate. I think for those workflows, there's nothing like it in the industry on the market.
I feel pretty certain that you've heard some interesting stories of how people push their Macs to the limit. So I'm curious if you could share any story about people using their Mac in a way that impressed or even shocked you?
I'll start that off with some more general answers to that, and Anand and Tuba may have some specific fun examples. But we've been developing Macs for our Pro community for a very long time, and we're so inspired by what they do, and that really is what drives us to constantly be pushing the capabilities forward. And so when we talked about these latest MacBook Pros with Apple Silicon, we talk about how it's just been a complete game changer. And we don't just say that. We're hearing these examples of these amazing scenarios of what it truly has enabled for creative pros, whether that's a photographer who wants to go out into the wilderness to take photos and used to, have to lug and carry all this equipment, who now, because the performance and the amazing battery life, is fine to go out, on that expedition carrying his latest MacBook Pro, to folks creating musical scores that can just tax the system in incredible ways, but they're able to do that all on their notebook and, not have to be back at the studio, and they can be cross-continent working with the studio and able to piece that all together. And so these ideas that you don't have to be in the edit bay in the studio, that you can be remote, and not only be remote, but you can get that same performance that you would have whether you're plugged in or on battery. And that's been huge for our pros as well.
Just to follow Laura's comment, like we've seen singer-songwriters recording songs on their MacBook Pro with the built-in microphone because they don't have the fan noise interfering anymore. And they can just take that workflow wherever they want, wherever that creative idea comes in, and they can just create, which is really delightful to see. And also, personally, I'm a very outdoorsy person. I go camping all the time. And every time I see a camper van parked and you see someone with a camping chair with a MacBook Pro just doing their work on the side of the road, it's just so great to see that. It feels like we're enabling more people to do their work wherever they want to be. And it's really great to be part of that transition.
I remember prior to the launch of M1, there was a part of me that was like, I don't know if people are going to get this until we launch, M1 Max and M1 Ultra, and almost feeling like M1's nice, but it's the small chip, right? Mm-hmm. Like, how excited are people going to be about it? And we knew how fast it was going to be on paper, but there's a difference, right? When you go and actually use one of these machines. I remember I moved my personal machine at the time to an M1 Mac Mini. And it feels like alien technology, right? Like, it feels so fast. At that time, it was like the fastest desktop I had access to, right? Like, it was a game changer. And then to be able to have that same sort of snappiness and responsiveness and all of that in a notebook with like a battery that just felt like it lasted forever, that to me was, even as someone who knew what to expect, it still felt unexpected.
When we first started using an M1 and the MacBook Air, we're testing everything. We're using it as much as we possibly can. And we just noticed that the battery indicator wasn't moving. And we all thought there's got to be something amiss here, like what's happening? And so I think to Anand's point, that's really interesting how on paper, we knew it was supposed to deliver these things and the promise of it, but to actually experience it, what started to get pretty magical.
Now, I'm on the other side as someone who takes in the Apple events and then test the products afterwards. And I remember a lot of us, when the initial M1 was announced, were like, there's no way. Like, what are they talking about? There's no way. And then we get them in And it's exactly how it was presented. And so many people were blown away. It felt like alien technology. And I'm actually currently using the M2 Max 16-inch MacBook Pro. And I was on a cross-country flight last week. And for the first 2 hours, I was doing video editing. And then I started getting worried because I was thinking to myself, I know they said 22 hours of battery life, but that's video playback and I'm doing video editing. How long is my battery going to last? And so I glanced up at my battery after 2 hours of editing, and I had 92% battery life left. Like, I'm video editing. So for me, it's still mind-blowing, and I can't wait to see what you guys have up your sleeve next.
Yeah, M2 Pro and M2 Max, they're really just better versions of what we've shipped before, right? Like it's that same great formula, that same power efficient performance, and you just get more.
Yeah, and I think that's the key thing, like with M1 MacBook Pro in 2021, like that laptop was incredible. Like performance was awesome, the power efficiency, and then it came with an HDR display, which is huge for the Pro community. And then with M2, now we have 96 gigs of memory. So if you're a Pro that needs that little bit extra, you got it. And, we'll keep innovating. So it's just very exciting to be part of this journey.
I like how you called 96 gigs a little bit, just a little bit.
It's wonderful.
Okay, I think that's time. So Laura, Anand, Tuba, thank you so much for taking the time and joining me today to talk about the Mac and Apple Silicon. I really appreciate it. I hope you guys found that as interesting as I did. I've actually been a fan of Anand since I started reading Anand Tech way back in 2004. As before joining Apple, he ran a PC hardware review website. As you probably know, Apple hasn't generally been known to do these kinds of on-the-record interviews that often, so it was definitely an exciting privilege to get this opportunity. If you have any questions on anything you heard, please drop them in the comments below, and I'll do my best to get the answers. Thanks for watching as always, guys. I appreciate your support. I'm Andru Edwards, and I will catch you in the next video.